Welcome to the course on basic genetics. The three teachers are Dr. Richa Arya, Professor Madhu Gavaldas Tapadia, and myself Jagat Kumar Roy. We are from Department of Zoology, Banaras Hindu University. This is week 10, fourth lecture. The topic is nomenclature of G-bands. In my last lecture, you have seen how G-band look like. We did talk that this is one of the banding technique which started long back, and still this is one of the best banding technique, and everybody is following this. Here, every chromosome, it is very clear to all of you that every chromosome appears banded and they have specific bands. Because of this specificity, one can always pair them easily, or one can number. If suppose one wants whether this belongs to chromosome 4 or chromosome 5, immediately with the banding pattern, one will be able to say this is chromosome 4, not chromosome 5. So this is how G-band has given us a very good kind of tool for studying chromosomes. Now, these bands, we are seeing these bands, these are the bands. Are there some kind of nomenclature that one should follow? That is what we will be talking today. I had shown in my last class that these are the G-banded chromosome, and here these are the dark bands, and these are the light regions. These are the light regions. So these G-band positive regions are Giemsa dark staining regions. They are stained by, because why they are dark? Because they are stained with Giemsa. They are heterochromatic in nature. Are there heterochromatin interspersed with the euchromatin? Yes. These regions which are light in stain, they are euchromatin. They have the functional genes, and the heterochromatin essentially is the intergenic region, where essentially genes may not be there. So, the G-band negative regions are Giemsa light staining regions. They are euchromatic and not AT rich. When we talk about the numbering of G-bands, so the numbering is given from centromere towards telomere always. In my last class, I did talk that which one is P arm, which one is Q arm. We did talk P arm is the short arm and Q arm is the long arm if it is a submetacentric chromosome. If it is an acrocentric chromosome, P arm is very short or almost not existent. Q arm there is the main arm. If it is metacentric, P and Q both are same. This is a pictorial representation. Why pictorial representation? Because this will give you a very clear idea about the bands, about the interbands, and about the subdivisions of bands. So here this chromosome, this has one band, two band on this side, 1, 2, and 3 bands on this side. So P arm has band 1 and 2. Q arm has band 1, 2, and 3. This is 3. So how? If imagine this is chromosome 5 and we have to refer to this band. We have to refer to this band. What we will say? Chromosome 5 and this is P arm, chromosome 5, P arm, and band number 1. So this is how one gives the numbering of the band. As it is written here, from centromere towards the telomere, the bands are numbered on P arm as well as on Q arm. So in P arm, the bands are 1, this is first band, 2, this is second. So because this is 5th chromosome, because this is P arm, the band 1, so 5P1, 5P2. In the Q arm, you have 5Q1, this is in Q arm, 5th chromosome, band number 1. Then 5th chromosome, Q arm, band number 2, 5th chromosome, Q arm, band number 3. It goes like this. If suppose we have better resolution of the chromosome. For example, initially when we were seeing this, we were seeing in high power. Now we are seeing it in oil resolution, that is a resolution much better than this. Under that condition, each band, these are the major bands. So each band shows further sub-bands. So these are sub-bands that are seen. So here, this band has 2 bands. How you will name it? This was 1, so this is 1, 1 and 1, 2, not 11 and 12, mind it. This is 1, 1 and 1, 2, because the first band has one more band and the second band. So that is why this is 1, 1, 1, 2. Many a times people say 1.1, 1.2. It is not so. That time the point nomenclature had not come. So that is why 1, 1, 1, 2, 1, 3, it is like this. Same way, band number 2 has 3 sub-bands. So 2, 1, 2, 2, 2, 3. In the Q arm, band number 1 has 2 bands, sub-bands, 1, 1, 1, 2. So you will call it as 5Q11, 5Q12. 5 is 5th chromosome, Q is the Q arm, and 1, 1 is first band, first sub-band. The second one, 5th chromosome, Q arm, first band, second sub-band. So that is how the nomenclature goes. On the other side also it is the same, 5P11, 5P12. And once again I make it very clear, it is 1, 1 and not 11. Because the moment you say 1, 1, that means this is part very close to the centromere. If you say 11, this may be quite far from here. So that is not the case. Now, the G banding can be done at a higher resolution also. Higher resolution means, so far in these, the chromosomes were metaphase chromosome. Now, if suppose you take pro-metaphase chromosome, they are much longer. Because they are much longer, more number of bands may get resolved. And if it is so, then that has to be given number. So here in this, the same has been done. You can see here, this is the centromeric region, this is the centromeric region. This is band 1, 1. This band's band number 1. This is this band's band number 2. Here, this one is having further 2 bands. So this one, I am talking about high resolution banding. The chromosome itself is long, and in that the banding is, G banding is done. So we will have many more bands. Here band number 1, 1 is resolved into two bands. How we will call it? We will call it as 11.1, 11.2. So at this moment the point has come or decimal has come. Then 1, 2. 1, 2 has been subdivided into 12.1, 12.2, 12.3, 12.4. Means this thick band is subdivided into 4 bands. Then this 2 has again 2 bands. So this is 22.1, 22.2 like that. Same way, in the other arm also you have 11, 12, 21 has to 1.1 to 1.2. That means this is subdivided into 2 bands. You can see here, you can see this. This is subdivided into 2. Same way 2.2 is subdivided into 2 bands. So here, as I was saying, that band 22 has 2 more bands. So it is 22.1 to 2.2. Same way, 23 has 3 bands, this to this. So this is 23.1, 23.2, 23.3, like that. 3.2 also has 2 bands, so 32.1, 32.2. 3.3 also has 3 bands. You can see this 3 bands. So this is 33.1, 33.2, 33.3. So this way the sub bands are classified. So if I have to say chromosome number 5, position Q, and second band, first subband, and first sub-subband. So I'll reach here. 5Q, this is Q arm, this is 5th chromosome, Q arm, band number 2, this is band number 2, this is band number 2, 1, this is 2, 1, and 0.1, this is 0.1. So this way, each chromosome can be very clearly subdivided into different regions. And these regions are very important because when we did banding, that time our aim was to subdivide chromosome into different regions for identification purpose. Now the next purpose is not simply the identification. It is to know which region, if suppose there is some abnormality, exactly which region has the abnormality. Whether we can go to the level of gene and say these possible genes are not there, and that is why these kind of high resolution banding has been done. So this is very, very useful, and with this I will go to the activity and discussion. I will suggest try numbering G bands as a part of your exercise. So you take G band chromosomes and you do exercise that this is band number 1, this is band number 2, this is band number 3. For each chromosome, you can say that this is chromosome 5, this is band chromosome 6, this is the band, and so on. And I said that why do we call these subbands as 1, 1 or 1, 2, not 11 or 12? Because the P arm or Q arm, P arm is the top one, Q arm is the bottom one. They are being subdivided. If it is 11, that means 11th subdivision. 11th subdivision will go somewhere near the telomere, and subdivision, division 1 will be near the centromere. So there is a big difference, calling 11 and calling 1, 1. 1, 1 means band 1's first part, and 11 means the other region. But then immediately you will ask a question that if suppose you have a band that is actually fifth chromosome Q band number 11, and another person is talking about 5Q band 11. So will there not be any confusion between 11 and 11? People following this kind of nomenclature, they have screened all the different chromosome, how many G bands are found and all this thing, and they have not come to a chromosome where the main bands are above 9. In fact, in human it is up to 7 only. So that means that kind of condition is not there, that the main bands are number 10, number 11 and so on. So you have the up to 7 or so and then region, sub-region of that. So I thank you so much.